All right, well, welcome to this webcast on introducing Apache Spark into your big data architecture. This event is brought to you by Think Big, a Teradata Company, in conjunction with Cloudera. My name is Paul Barsh. I am the Marketing Director for Think Big, and I will be serving as your moderator today. Now, before we begin the presentation, I wanted to go over a few housekeeping items. So the first one is feel free to resize any of the windows on the screen, including the presentation window, and move them around so that you can best view the presentation. At the bottom of your screen, you will see a taskbar with icons. So take a look at that real quick. If you're unsure what an icon does, just hover over that icon with your mouse, and a box will pop up that tells you the function of that icon. There's also some social buttons on the upper right-hand side of the screen. Now, they allow you to connect with Think Big on social media, both now and after this webinar. There's also a chat feature. You'll see that on the right-hand side of the screen, and you can use that live chat feature to reach out to me as the moderator during the webcast, or use the chat to connect with your fellow attendees. We often get this question a lot, and people ask, hey, where can I get the slides? Where can I get a copy of the slides? The answer to that is the copy of the slides can be found in that handouts window. So look at that on the bottom right-hand side. It's the paper icon at the bottom of the screen. You click on that, and you will see the webinar slides. And this is an important part. You can participate in the Q&A session by asking questions at any time during the webcast. So if something piques your interest, feel free to use that Q&A button right there and open that up and type your question into the box and then hit submit. And also, if you need technical assistance throughout the webinar, perhaps you're having some issues, submit a question through that Q&A panel and we will write a response back to you. All right, so now it is my pleasure to introduce our two presenters today. First one, we have Anand Iyer. He is a senior project manager at Cloudera. His primary area of focus are platforms for real-time streaming, Apache Spark, and tools for data ingestion into the Hadoop platform. Before joining Cloudera, he worked as an engineer at LinkedIn, where he applied machine learning techniques to improve the relevance and personalization of LinkedIn's feed. He has a master's in computer science from Stanford and a bachelor's from the University of Arizona. Can I get some assistance on advancing the next slide? I'm having some challenges with that, just so we can see the presenters.
Hey, Paul, we are on the next slide.
Okay, good. That's great. There's something with my particular console. It's not showing a refresh, so that's great. Thank you. All right, our second speaker is Eliano Marquez, Principal Data Science and Data Science Global Practice Lead at Think Big Analytics. Recently, Eliano has been focusing in developing analytics solutions for customers around predictive asset maintenance, customer path analytics, and customer experience analytics, with a main focus in utilities, telcos, and manufacturing. Eliano has a Master's of Science in Applied Econometrics and Forecast from ISEG Lisbon. All right, if we could advance to the next slide for the agenda, because I don't have the ability to do so. All right, thank you. Thank you. So today we're going to go over what is Apache Spark. We're going to look at where Spark fits in Hadoop's ecosystem. We're going to hear from both companies on use cases and customer examples. Eliano is going to explain some common challenges for Spark adoption with data science users. There's going to be a discussion on 4 strategies for proving business value from Spark engagements. And then I think this is going to be a fun section. We have 3 gotchas for Spark users and how to avoid them. And then we'll go into the open Q&A. So with that, let's turn the presentation over to Anand. Thanks for joining us today. The floor is yours.
Thanks, Paul, for the introduction. So let's start by talking about why Apache Spark is so popular. The biggest factor perhaps is the fact that it is fast. And when we say fast, fast is a relative term. We're talking in relation to its predecessor, which was MapReduce. Spark is an order of magnitude faster than MapReduce for general purpose big data processing. And in fact, in the next slide, we'll do a deeper dive into what makes Spark so fast. But speed is only half the story. Spark's rich yet easy to use API is a major factor for its popularity and fast adoption. These APIs are available in Java, Scala, or Python, thus covering the popular programming languages out there. And they embody a functional coding style, and hence the code often tends to be easy to read, easy to author, and very succinct. In addition to the niceness of the API, Spark also comes with an interactive shell or REPL that basically enables you to write little snippets of code and run them instantly. So basically the development process also becomes more interactive rather than writing code, compiling it, deploying it on the cluster, seeing that it fails, and then going over that loop over and over again. The REPL just makes the whole development process a little bit more interactive and easy. And despite the richness of the API that Spark provides is also very flexible and extensible. And that's exemplified by the various higher order frameworks that have been built on top. For example, there are rich frameworks and libraries for machine learning, graph processing, and so on. Now let's take a deeper dive into the internals of Spark and understand why it is fast. When you author a Spark job, you're effectively defining a directed acyclic graph of operations on large distributed data sets. These data sets that are distributed, these are data sets that are distributed across a cluster of machines, and they're known as resilient distributed data sets, or RDDs. That's the terminology that Spark uses. So in the context of Spark, you'll often hear the term RDD, so it's a term that you should remember. Spark applications are effectively a sequence of transformations on these RDDs. Each transformation will take one or more RDDs as input and produce another RDD. This sequence of transformations, or rather the directed acyclic graph of transformations, will culminate in what is called an action, and an action is essentially where you take the final RDD and synthesize your end result. Of course, Spark applications run on a cluster of machines. We are talking about distributed computing. Thus, these large distributed data sets that I mentioned, the RDDs, are held in the worker nodes of the Spark application, and those worker nodes process the chunks of these RDDs in parallel. So that, at a high level, is how Spark functions. Now, one aspect of Spark's speed is down to the fact that Spark can cache these RDDs in memory. If an RDD will be reused, you can keep it in memory to prevent redundant I/O. There's no point in writing it to disk, rereading it from disk, and each time you do that, you also pay the cost of decryption and deserialization and so on. That is redundant. So what Spark does is it lets you keep these reused large data sets in memory. And what we've observed is that the price of memory is dropping. We're seeing Moore's law apply to memory, and that trend is likely to continue. So a system that can maximize the usage of memory is very compelling. The other piece is that not all intermediate RDDs are written to disk. Now, as we mentioned, Spark applications are a sequence of transformations, often a reasonably long sequence of transformations, which will produce many intermediate RDDs. But not all these intermediate RDDs are written to disk. They're kept in memory on the executor nodes or the worker nodes of the Spark application. But hey, we're talking about cluster compute. And we know that when you're running applications on a cluster of machines, processes will fail. Machines will crash. How then does Spark achieve fault tolerance? How can it recover lost data when a process crashes? Well, it does that by leveraging a concept called lineage. Lineage is essentially retaining knowledge about the sequence of actions that were applied to produce a particular data set. And when a chunk of a data set is lost, Spark can quickly reapply those transformations and reproduce just the lost data. Now, that does not mean that Spark applications never write to disk. In fact, despite the whole in-memory processing label that is associated with Spark, one must recognize that Spark does write to disk at specific intermediate points, and these are usually called shuffle stages. And of course, last but not least, when we're talking about performance of a distributed computing framework, you need a very fast and efficient scheduler, which will schedule the various computational units to process these distributed data sets fast and efficiently on the various executor or worker nodes. So at a high level, it is the combination of these factors, the caching of data sets in memory, lineage to avoid writing intermediate data to disk, and efficient task scheduling that makes Spark fast. Now let's look at some numbers that depict the popularity and fast adoption of Spark. Let me give this slide a second to refresh. Let me know, guys, if you see the slide. It's titled "The Popularity of Spark." Looks like it's slow and refreshing on my browser. All right, there we go. Cool. So the popularity of Spark. It is, at this point, the most active project in the Apache ecosystem. It has, in fact, on this slide, I've written 750 contributors, but I recently found out at the most recent Spark Summit that Spark has received contributions from over 1,000 contributors. And these are contributors from various organizations across the globe. At this point, it is adopted by all the major Hadoop and big data vendors as well. Now let me give you some usage statistics that I've observed from Cloudera's customer base. At this point, we have over 170 customers running Spark in production. And we're talking about 170 large enterprise customers. The adoption is across various industries and use cases. Spark is no longer a niche platform used for a subset of use cases. We've seen Spark run on really large clusters. There are a bunch of customers running Spark on clusters with over 1,000 nodes. So where does that leave Spark in relation to the rest of the big data ecosystem? What is the position of Spark with the various other technologies out there? Spark will essentially replace MapReduce as the general purpose data processing framework of Hadoop. Batch data processing jobs that crunch through large quantities of data will be authored in Spark. And of course, Spark will be complemented by other fit-for-purpose engines in your overall big data architecture. For example, a highly tuned and optimized system like Teradata will be used for low latency reporting and BI. You may use SQL on Hadoop engines like Impala or Presto for more flexible interactive BI on non-relational data sets in Hadoop. You'll use NoSQL stores like HBase or search systems like Solr for fast serving of data. And Spark will be used for most other general purpose big data crunching, and also increasingly for real-time stream processing. And I'll actually talk a little bit more about stream processing in a subsequent slide. I want to give a quick mention to the One Platform initiative, which is an initiative led by Cloudera to deeply and broadly embed Spark in the Hadoop ecosystem. And the other key tenet of the One Platform initiative is to improve and accelerate the enterprise-ready capabilities of Spark. Spark, one must realize, is still a fairly nascent project. It has seen tremendous improvement and adoption over the past 2 years. But of course, there's a bunch of work that still needs to be done before all enterprises across the globe can use Spark for mission-critical applications. And right now, the community and Cloudera are at the forefront of that movement to make Spark enterprise-ready and seamlessly integrated with the other components of the big data ecosystem. Let's look at what the vertical software stack looks like when you're running Spark applications. Your data, of course, will reside in a scalable, cheap storage system like HDFS, or it could be NoSQL stores. If you're running in the public cloud, your data is probably on an object store. Then, of course, you need a resource management layer like Yarn, which will provide multi-tenant access to the resources of your cluster. And this is critical because Spark by itself does not manage the resources of the cluster. It relies on the resource management layer. It relies on the resource management layer to manage resources. It will negotiate when it needs additional resources, Spark will negotiate with that resource management layer to acquire resources. And when it's done, it will relinquish those resources to the resource management layer. And this is critical for efficient multi-tenant usage of your cluster. We usually recommend running Spark on the Yarn resource management layer. So now let's look at Spark Streaming. Spark Streaming is a very compelling extension to Spark, which lets you process continuous streams of data in near real time as the data is streaming in. It takes the continuous streams and it discretizes them into what are called micro batches. And it processes these micro batches in fast succession. It effectively lets you process the events in a data stream almost as soon as they're produced. Now, Spark Streaming by itself can be, the topic of an entire webinar. So, we'll have to just do a quick mention of it and move on. But I do want to call out the fact that we're seeing usage of Spark Streaming across industries and various use cases. So online fraud detection is a rather obvious use case that comes to mind, but there are many other use cases, online recommender systems, real-time patient monitoring, and so on and so forth. We're seeing tremendous adoption of Spark Streaming in the customer base. Next, let's talk about Spark SQL. And if you're keeping track of the developments in Spark, you'll realize that Spark SQL is probably one of the newer, more popularly mentioned additions to Apache Spark. So what is it? Data, big data even, inherently has some structure. Let's look at JSON files, for instance. A JSON file has records where these records have named typed values. So the information about the types of the fields in a record enables two things. One, it enables an easy representation of the data in your code. The API will allow easy representation of that data, and that is what the data frame concept embodies. A data frame is nothing but a list of records which have typed named fields. And of course, the other piece is when you know the types of the fields in the records, the query, the processing engine can leverage that type information for some automatic under-the-hood optimizations. And that is what Spark SQL provides, and that is why it is compelling. With Spark SQL, you get to load data from JSON files or Parquet files or Avro files as these data frames, which have named typed columns. And then you get to author computation on those data frames with SQL statements and leverage a query processing engine that will apply automatic optimizations for those SQL statements. The primary usage of Spark SQL will actually be as embedded SQL statements within your Java, Scala, or Python Spark jobs. The value of embedding these SQL statements in your application code is the ease of authoring your code, and also, as I mentioned, the ability to leverage a query optimization engine for optimizations in these SQL statements. And of course, the other advantage that is really compelling is the ability to interweave these embedded SQL statements along with fully arbitrary processing of your data as RDDs. So this ability to go from SQL statements on structured or semi-structured data and then falling back to fully arbitrary processing on RDDs, and the ability to do all of that within the same Java, Scala, or Python application is incredibly compelling, and that is the key value proposition of Spark SQL. I want to hand off the slides, the presentation to Eliano, but before I do that, I do want to give a quick mention to MLlib. MLlib is this rich library of machine learning algorithms that has been authored on top of Spark. It is a part of the Apache Spark ecosystem. Again, MLlib is one of those vast libraries that can be the topic of an entire webinar by itself, but I do want to call out the fact that it is seeing tremendous adoption, and it has a fairly rich collection of algorithms that cover most of the broad, popularly used sections of machine learning. And with that, over to you, Eliano. Eliano?
Thank you, Anand, for handing over, and thank you, Paul, for the introduction. Good morning or afternoon, everyone in the webinar. So again, some of these topics around the excitement around Spark has already been covered by Anand in some of his slides. Of course, we talked a little bit about the speed element of Spark, and here really the tool and the framework around Spark, both on the SQL, MLib, and then the streaming as well, has gone through a series of benchmarks, and the performance that you get out of the tool, it's really interesting, and from a scalability perspective as well. I mean, again, Anand shared some of the clients that have been running Spark with over 1,000 nodes on this cluster, and we have seen different types of adoptions. Start small, scale fast with your business needs, but also clients that really started already with big clusters. And the great capability that Spark brings to the table really is around enabling the frameworks that we have been talked before about SQL and Web and streaming, and actually being available at scale. And so you don't have to change the underlying code to go from one to the other. It actually scales out of the box, and that's really fantastic. From a flexibility and integration, I guess the key point that I want to call out for all of you that are out there is it's not just about the APIs. It's not just about the Python, Java, Scala, or R API, but actually how flexible Spark these days are to integrate with other tools, both from an upstream perspective and downstream perspective. In other words, so today if you want to bring data that is actually sitting on a relational database, it's actually very easy to do that. There has been a tremendous amount of effort from the community to extend some of the data sources that are available out of the box on the tool to enable you to bring data from multiple sources as well as Hadoop, of course, but that will expand and give you much more flexibility. So if you're doing an analytical project that requires data that is sitting in HDFS, but in addition to that you have X amount of data sources that sits in a business, and you want to bring all of that together to create some insights and generate value out of the Spark cluster, that really is very possible with today's state of the art of the tool. And of course, you're benefiting from the tool being in the Hadoop ecosystem. Fantastic statistic about 1,000 contributors, and it's continuing to grow over time. So it's really a phenomenal increase in the amount of developers that have been dedicating time to commit great extensions to Spark, and we're going to talk a little bit more about that in the next slide or two. I want to call out something that it's really important. Around the community, we talked a little bit about the developers, but not just the developers. Today, when you really want to solve a code-related issue, or you want to know how to get started, or you want to go through a set of examples, today you go to GitHub, you go to Stack Overflow, or you go to Jira, and you are very likely to find a way to start, rather with Jupyter and some notebooks that enables you to start writing some Scala or Python or R code and interact with Spark, or just simply trying to understand how this model is performing versus the other. So all of that support from the open source community, it's really important. I have to call out as well the documentation from Spark itself for all the frameworks around it, which is really good, and it really enables you to really get started very fast. And finally, the relevance of plugins and events and news that is also available for anyone that really wants to become a developer, a data science on Spark. So there is, of course, the Spark Packages portal, Spark Hub. There's a lot of events and news available on ThinkBig portal, Cloudera portal, and other providers out there that are really spreading the word around Spark, that for us that are in this field and really want to solve business problems faster with recent and modern technologies, I mean, that's really great for us to be aware of. So what I will do, and what we're going to walk you through now, it's essentially two use cases. And before we really start deep diving into the first use case, I think going forward, more often organizations will ask this question. I already have Hadoop. I already have a data lake implemented. I already have Spark. I don't really know what it is, or I really know what it is, but I already have that implemented. There was already an investment made by some area of the business, made by IT. And the question that I have now is, would my use cases, my business problems be able to be solved by Spark, leveraging the production environment that has already been created? Okay, so it's not a case of always getting started from the scratch, but more often as organizations evolve, they already have the Hadoop appliance installed. They already have Spark. They just need to be aware that some of their use cases can be solved with Spark itself. So this example, we're going to keep it at a very high level. We'll deep dive into the second one, more into the details of it. But this example is just to give you an idea about an organization that engaged with us to really try to understand what use cases that traditionally was solved on other tools or technologies, to really understand if that use case could be solved by Spark, and could be solved on top of the existing framework and infrastructure that they had in place. So one of the key questions that they had is, they had a manufacturing process to produce a specific product, and they were kind of interested in knowing, for example, could we understand the relationships between product yield and some of the media data that we could collect from the historical releases of products, and what would be the relationships between that, the production process, and try to understand the relationships so that we can predict going forward if there will be a product yield increase based on the way the communication is being made related to that specific product. And what I'm trying to call out here is less about the frameworks, the tools, but it's making sure that the business really start to make these questions. Can I leverage what already has been implemented and actually extract more value from it by asking different questions, bring more use cases into Spark? In this case, they were really interested to understand, does media affect product yield? And I mean, we've done, of course, the project. At the end of the day, we found some very standard outcomes that when you're blending new data together, you may realize that the quality of your data is not as you expected in the beginning. We tried different algorithms. We leveraged PySpark API in this specific use case. And at the end, we were able to conclude, based on the different algorithms and libraries that we applied, that media didn't seem to influence that much product yield. So going forward, we were able to provide some guidance and indications about the relationship between products and media interactions. That for the client was very good to know. But the question that I also want to leave in this use case is, for example, if you monitor and have a production model that is doing this relationship going forward with any other product, how much benefit this organization will have by essentially measuring these relationships on an ongoing basis. And this solution, perhaps with the traditional environment they had in place, wasn't able to be developed because all the amount of data that it's required to blend all the media data with the production process, it was just difficult to handle on a single node. So again, a great use case, not from a technical perspective. We'll have a second use case that is more technical oriented, but I just wanted to leave this very important message. As the organizations evolve over time, they will have already Hadoop in place, they will have already Spark in place, and the question will be, can they leverage and capitalize that investment to bring other use cases into the platform? We'll move into the second use case. And this is a very interesting one. We talked a little bit about recommendation engines. And so this use case is just trying to understand how can analytics help this specific organization increasing user section length. So essentially, somebody is on an app or on a portal online, and they really are interested in keeping that user as long as possible on their portal, on their app. And what I want to call out in this use case is how Spark is being used as a generic framework to essentially produce the outcomes that we were engaged with the client to do. So in this case specifically, you're looking at two different ways of leveraging Spark. So the first arrow that you see, the green first arrow on the top, essentially is linked to the production process in Spark. And that production process, what essentially is doing is accepting data from, in this case, Amazon shared file system, in this case S3, which will provide them X amount of data schemas and then data that essentially has been stored in S3 online, and start making transformations, leveraging, for example, DataFrames, Spark SQL, and so on and so forth, to really transform the data and essentially store that data into HBase. So in this particular case, what is really important to call out is Spark is being used as a batch tool to really transform the data into a format that a further downstream application like HBase is expecting, and is doing that continuously. In addition to that, within the process of receiving data from, in this case, data is being ingested through a batch process. In addition to only transforming the data, we were also performing some of the predictive models, leveraging Spark APIs, in this case PySpark or SparkR, depending on what you're trying to do, but essentially combining a process, a production process, combining it with the machine learning libraries that Spark has, and storing their outputs on HBase or another model consumption environment that will receive the metadata of the model to be further down the stream consumed by other applications. So very important to see the general purpose of the tool. So it's being used on the same batch process, but one is making transformations and preparing the data to be stored on HBase for future consumption of tools, and we'll talk a little bit about that in the next slide. But in addition to that, is also being used to run predictive models continuously. And that is exactly one of the key fundamentals of Spark, is you, within the same tool, you can leverage both without having to change the way you program, without having to change the language that you're using. In addition to that, on the bottom green arrow, you're looking at Spark streaming. So some of this data that is coming for this specific recommendation engine will come almost in real time or in real time. And you can see there that we are leveraging Kafka, and then Kafka essentially we will send those streams directly to Spark Streaming, so that that framework will perform similar transformations that the batch process is doing, and also store that information to HBase to be further down the stream analyzed by other visualization tools or processes. So within the same architecture, within the same solution, you pretty much can be using all the Spark frameworks in order to solve the business problem. And that's quite unique. That's quite unique from a tool perspective. And that's a very important point that we are really trying to call out here. Secondly, within a production environment, we keep talking about how we essentially can accelerate the process of doing data science on top of the cluster without having to force all the data scientists to go and use terminals and black screens so that they focus on the business problem instead of the technology. So here we're just providing you an example of how can you enable Spark through the APIs that we talked throughout the presentation around Python and R with tools like RStudio, Jupyter, or Zeppelin to enable the discovery analytics, to enable the models to be developed on an agile framework, still leveraging Spark, but not having to go inside the cluster and run everything via the terminal. And important as well, and again, we'll talk a little bit about this later on, is if you're really trying to use BI and visualization and reporting tools on top of it, you might have to consider something else. We'll talk a little bit about that at the end, but keep in mind that while it's a fantastic generic purpose tool, it enables you to, again, run batch process, make transformations, link Spark itself with further downstream applications. You can also use it for data science. We talked a little bit about DataFrames, about machine learning, but when it comes to integrating with other visualization and reporting tools, perhaps you need to have a look at something different. And we will stop into the use cases and we'll move into a different type of messaging, but I hope it's really important for us that you really understand that from a business perspective, when you have use cases that you're trying to solve, you really look at Spark as a generic purpose framework that enables you to leverage machine learning, SQL, real-time or near real-time with Spark streaming, and still be doing all of this within the same framework, within the same tool, within the same language. So again, of course, I will always be a little bit biased towards data science and analytics, but I mean, if you had to think through how we would transform Spark to be enterprise acceptable pretty much across all the globe, across all organizations, there's a few things that I really want to call out here. And I kind of spoke a little bit about them throughout the way. But the first one is really tools and access, right? Not all the analysts, not all the analytical practitioners out there will be encouraged or will have the access or will have the time to go and access terminals, deal with proxies and deal with configurations. They really should be focusing on business problems. They really should be focused in making value for their organizations. So it's very important that when you are enabling Spark within the organizations, and again, leveraging open source technologies, it's important to call out exactly that, you need to find a way to enable both like Scala, Python, R, but enable that with user-friendly tools that enable them to start fast, learn throughout the way, but focusing always on the business problem. So here you have an example of, you really have Spark as an engine under the hood with all the 4 APIs, and then kind of the streaming, the SQL, the machine learning, the graph, all of that available. But instead of enabling that through terminals, make that available via a browser. Make sure that you implement the right tools that are accessible through the browser, and let your analysts and data science and analytical practitioners consume that on a very user-friendly way. So when they are analyzing, when they are using Spark, they can say, oh my God, that's very simple to use Spark to solve this specific business problem. So I think this access and tooling will be very important to essentially enable large or more organizations adopt Spark at scale. Second one is around algorithms and plugins. So today, Anand was presenting a few algorithms available on MLib, but I just want to call out that it's important to look at Spark and the amount of plugins that have been created in the Spark package ecosystem. So today, if you're solving a business problem and the algorithm that you're trying to do, it's not out of the box available, you have other options. So don't look at the Spark MLib or any other framework and say, oh my God, I'm only restricted or limited to these algorithms. You really should, and I recommend all of you to look at Spark packages, to look at other open source libraries that integrate natively with Spark, such as H2O, and really see if some of those frameworks will help you solving those business problems. If it does, excellent, fantastic, so you can leverage those and put your business problem again, solve your business problem with these additional plugins. I just had a look a few days ago, and there's about 52 related machine learning packages on the Spark package portal. So that means that X amount of developers, X amount of practitioners of Spark practitioners are already developing and extending MLib to incorporate other algorithms, other processes, other methodologies that will help us solve business problems. Or you can, if you want, see how a Spark package is created and extend the algorithms yourself. Of course, this in an organization will require time, but I mean, if you really can't find anything, I mean, perhaps that would be an alternative that you would like to have. But again, from a business perspective, if you're a business department or if you're trying to solve a use case and it's not available on out of the box on MLib, research, see what's available on Spark packages, and see if you can solve the use case that you're trying to do with those extensions. Finally, user resource and management. So again, you need to make sure that you provide the right access to the group of data science or analytics that you have in your company, but you also need to manage and control and have the right governance in place for them. Because otherwise, I mean, if you don't think through that process when you are enabling that, and if perhaps a data scientist writes a loop, and that loop is essentially using all the memory of the cluster, out of a sudden all your production process may not be running as a result of that. So it's very important that you create a user group for data science, you essentially allocate the right resources for them, and you monitor that over time. It's important to also monitor because, again, we would benefit from seeing the statistics around who's consuming what, and what can we learn from that to improve over time. So from that was quite a very important message around how would data science benefit from Spark going forward. But there's also a good point to make around how do you essentially measure business value from Spark engagements. And again, we are talking here about 4 ways that essentially would enable you to measure and the success from a business value standpoint when you're implementing Spark or when you're leveraging Spark. So the first one is, of course, if you're looking from a modeling perspective and just from a modeling outcome, if the performance and the accuracy of those models, independent if it's MWeb or other libraries on top of Spark, if it's improving the accuracy or the performance of those models, and then the increase in accuracy enables the business to act more effectively and make a gain, that's fantastic. So you essentially have your project paid off straight away. Secondly, it's how frequent can you update those models to continuously generate benefit for the organization. Right. Before, for example, if you're using traditional approaches or if you're using a single node tool, it might do the job, but if the learning of the algorithm takes 10 hours and you have 200 algorithms to train, then just think about how difficult it would be to update all of those models. But if within Spark it updates in minutes, you essentially are providing a more continuous and incremental gain for the organization by just updating more models more frequently. So a combination of accuracy with frequency of update, it's something that you really need to consider. Secondly, Spark, as we talked about scalability and speed, but also those two together enables you to analyze new data that you couldn't analyze before. Of course, you can say, well, I could bring all that data that I had before and wait 24 hours or 48 hours to get a new insight. But if you tell that to your boss, then you probably will be in trouble, right? So you really want to make sure that you can generate new insights faster and on a continuously basis. So if you are able to, at the end of a project, able to generate such insights for the client, for in this case, for the use case that you were trying to analyze, then that's really, really fantastic. From a number of users that are really leveraging Spark on a day-to-day basis. So for example, when you implement Spark and then none of your analysts or none of your data science are able to use Spark, and then out of a couple of weeks or a couple of months, you have a community, internal community that is really using Spark to drive some of the solutions, some of the business solutions for the use cases that they have. That's really fantastic, and that's really a way to show and prove the value of Spark. And those analysts and data science, they can continue to use and leverage Python or R. They might have to go to Scala sometimes. But again, if you have this community of users, internal community of users, that's really a way to kind of really think through the value that this solution is bringing. And finally, the number of use cases that can be used on Spark. Again, you might be talking about a pure ingestion project, that's absolutely fine, but think through, as I said, you might use Spark in the beginning to just solve one use case, but how many other use cases can you actually solve with the same infrastructure that you have already in place? And I think that's quite unique. And when I say different use cases, I'm not just saying apply for two use cases, one model each. I'm saying, well, for one use case, you might need to leverage Spark streaming, and then the other one, you might need to actually do some batch ingestion and make some transformations at scale, petabytes of data. And for the same two use cases, you can still use Spark. And that's really important when you're really looking at your organization and trying to come up with reasons to leverage Spark within your organization. So, I mean, we now going to look into 3 gotchas for Spark and how we overcome some of those issues. And I'll hand over to Anand now to talk about the first one, and then we'll pretty much each other will make some comments on each one of them. So over to you, Anand.
Thanks, Eliana. Cool. So yeah, let's address some gotchas which you may not be aware of or expecting when you deploy Spark. I mentioned Spark SQL, and I mentioned the fact that what is compelling about Spark SQL is the ability to embed SQL statements in your Java, Scala, Python applications and interleave SQL with arbitrary and general purpose processing of the data. But whenever someone says SQL, we naturally have or make the assumption that SQL must imply access over JDBC or ODBC that you can use as a backend for interactive dashboards like Tableau dashboards or other BI dashboards. Now, in theory, that is possible with Spark SQL. However, it's not ready for wide enterprise usage. For one, it doesn't have any security features. And whenever you're talking about BI that is going to be used across an organization, you do require proper authentication and authorization. Those features are not available at the moment. And the other piece is that just the fundamental architecture of Spark SQL's JDBC server is it needs a bunch of work. At the moment, it's a single point of failure, which is known to be unstable. It also doesn't have sufficient concurrency, and when you're talking about interactive BI, concurrency is important because you usually have multiple users logging on and issuing queries simultaneously. So even though it is possible that component is available, the JDBC, ODBC server for Spark SQL, tread very carefully if you're going to use that for enterprise usage, and it certainly will not be your go-to tool for interactive BI. For interactive BI, you want to leverage other more mature tools like Teradata or the SQL on Hadoop options like Impala and Presto and so on. Eliano, what are your thoughts on the API of Spark? I did mention that it's a very compelling API, but are there any limitations that you've come across?
So I think there's a few things that it's important to call out. For example, I know you would like to add some comments on the Python API, so I will make some comments on the R API. Again, R API, it's still on a very immature place right now, but I mean, when we talk about limitations, we first need to really say thanks for the development team that has put that together. It's already a great feature, and if you really are an R fan, you really want to leverage Spark R, it's really great for data transformations because pretty much all the data frame capabilities are already there. But when you're trying to use it from an end-to-end perspective and you're trying to combine streaming, not possible. When you're trying to combine machine learning with it, well, it's possible for one type, not for all. So it's still on a place where you would have, if you really adopt R, you would have to jump from one tool to the other to be able to really solve the business problem. So again, it's just be aware that you can use it, but you might end up on a situation where you have to, at some point in time in the project, you might have to go and try something else. What about production pipeline management? What can you say about that, Anand?
Yeah, that is a good question. So Spark is a fairly young project. So when it comes to production capabilities, there's certainly more work to be done. One area that comes to mind for me is running Spark streaming jobs, which need to be running 24/7. These are jobs that are running for months on end, continuously processing data. Spark streaming by itself at the moment lacks sufficient capabilities for proper alerting and monitoring of these jobs. What have you observed in general when it comes to deploying Spark, including batch use cases in production?
I think that the key point here that we're really trying to call out is it's not just about putting Spark and making and just putting jobs running. Having the right governance and monitoring of those processes is as important as really start writing some Spark scripts. You really need to have a complete end-to-end view about what process actually completed, the time that it took to execute, the resources consumed, which ones failed and restarted again, because that monitoring and that governance enables you to feel that you have the full control of what you have in production, and I mean we cannot emphasize how relevant that is when you really have a large number of processes running in production, and the effort that you may have just to understand what went wrong and what didn't and what was executed successfully may be painful. So just bear in mind that it's as important as making the process running, managing and controlling and governing them on the right way.
That's good advice, Eliano.
We'll leave some time now for questions and answers, so I'll hand over to Paul now.
All right. Hey, thanks for a great presentation, gentlemen. You've given our audience and myself a lot to think about. The good news is we have 17 questions. The bad news is we have about 5 minutes. So if we don't get your question answered, I have a lot of questions here. We can follow up with you. I appreciate all the questions, but let's see what we can get in. So the first question is, do you guys think that Apache Flink will replace Spark in the future? What are your thoughts about that?
Let me add some thoughts, and then Eliana, you can pitch in as well. So it's too early to actually come to any meaningful conclusion. Flink is certainly a compelling project, but in terms of maturity, Flink is where Spark and Spark Streaming were 2 years back, if not longer. So we don't know of too many production instances. And the other piece is Spark Streaming development hasn't stopped, so it continues to improve. Now Spark Streaming already provides fantastic APIs, incredible throughput. The one advantage that Flink has over Spark Streaming right now is the fact that it can offer lower latencies. What we've observed is that incredibly low latencies tend to be not relevant for majority of use cases. And for the small section of use cases where that incredibly low latency is relevant, Spark Streaming has a bunch of improvements on its roadmap that should address those. So time will tell, but at the moment, if I were a betting man, I would bet on Spark Streaming.
Sure.
All right, Eliana, any thoughts on that?
My only comment is I don't, at this point in time, I'm not looking at Flink as a replacement, but as an integration to Spark. And of course, from a streaming perspective, some of the comparisons and that are made seem to be very exciting, but the product is still very on an early stage. From an analytical perspective, for example, there's nothing really out there already that we can say it's going to replace. So at this point in time, the way I'm looking at it is how can I integrate Spark with Flink rather than how do I replace Flink with Spark? And then that's for me probably the key takeaway up until now.
All right, so Anand, I'll throw this one to you. It says here, why don't you simply use Hive instead of Spark SQL? We talked a lot about Spark SQL in this particular session, but why don't you use Hive instead of Spark SQL?
That's a good question. So firstly, Hive was built on top of MapReduce, and as we've discussed, MapReduce is an order of magnitude slower than Spark. There is a fairly extensive project right now to port Hive to run on Spark. It's called Hive on Spark project. It's available as a beta right now and will become production ready soon. But that being said, Hive on Spark is a layer on top of Spark, so it cannot inherently leverage some of the query optimizations that are inside the Spark SQL query engine. So you would use Hive on Spark if you're familiar with Hive and you have a large team of data scientists or analysts that are already familiar with Hive. You flip a switch, you run it on Spark. But for newer workloads that you author in Java, Scala, or Python, Spark SQL will be the way to go. But yes, there is always a gray area where either tool will serve your needs.
I'll just add, why don't you use Hive on Spark?
Yeah.
You can still do that and benefit from the engine itself.
All right, so here's the next one. What's your opinion on real-time streaming using Spark or Storm? Which is better?
Eliana, do you have any? Fair enough. So I guess the thing with Storm is Storm was the leader or the early leader when it came to real-time streaming. However, what was noticed was Storm's API was too low level, and the management of streaming Storm jobs was much harder than Spark Streaming. So Storm certainly has certain sets of use cases where it is appropriate, especially again where you need low latency or you need low-level primitives. but Spark Streaming's advantage would be an easier-to-use API with better throughput. So it does depend on the use case, and I do see a place for both engines, but increasingly the trend has been towards using Spark Streaming because it's a nicer API for majority of the use cases.
All right. Well, we're on the hour here, so let's wrap this up. This concludes our webcast on Spark. I'd like to thank Anand Iyer from Cloudera, and of course Eliano Marquez from Think Big. Appreciate your time, and appreciate the time of our audience. We hope that you found this webcast to be a valuable experience. If we didn't get your question answered, we will definitely follow up with you. There's a lot of good questions here and a lot of good opportunity for follow-up. So thank you for attending today.
Thank you, Paul.